This super series session, we are going to discuss some of the most important and repeatedly asking gate questions from state space equations on control systems. We have a circuit and we want to find the state equation for this current I1 flowing through this inductor. We have an independent voltage source Vs and dependent voltage source 0.2 Vx. We want to obtain I1 in terms of Vs and Vx. Options are given. We know that the value of voltage across this inductance is VL, that is given as L di by dt. So we can write this voltage, that is VL is equal to L di1 by dt, that is equal to 0.5 di1 by dt. Now apply Kirchhoff's current law at this node. Let this node be A. So the voltage at this node is same as that voltage across this inductance. So VA is equal to VL. So we can write VL that is equal to VA, that is a node voltage. Now apply KCL at these nodes. Now I am assuming all the currents are outgoing. So this current is going outside, this current also going outside, and this current is also going outside. So we can write the equation to this current, that is VA minus, then we are moving from lower potential to higher potential. So minus of minus Vx minus this Vs. That is a potential difference across this branch, all divided by the resistance 3. That is a current through this branch. Current flowing through this branch, that is VA minus of 0.2x. That is, we can write plus VA minus of 0.2 Vx. Since we are moving from lower potential to higher potential, that divided by the resistance, that is 5, plus this current I1, that is equal to 0. So we can write 0.5 di1 by dt plus Vx minus Vs divided by 3, this plus 0.5 di1 by dt plus 0.2 Vx divided by 5 plus I1, that is equal to 0 by taking the LCM. So we can write 0.5 di1 by dt plus Vx minus Vs, this into 5 plus 0.5 di1 by dt plus 0.2 Vx, this into 3 plus 15 I1, this is equal to 0. 4 di1 by dt plus 5 Vs plus 0.6 Vs. So 5.6 Vs minus 5 Vs plus 15 I1 is equal to 0. Now collect these three terms to RHS. So we can write 4 di1 by dt, that is equal to minus 5.6 Vx plus 5 Vs minus 15 I1. Now divided by 4. So we get di1 by dt is equal to minus 5.6 by 4 Vx plus 5 by 4 Vs minus 15 by 4 I1. This is equal to minus 1.4 Vx minus 3.75 I1 plus 5 by 4 Vs. So di1 by dt is equal to minus 1.4 Vx minus 3.75 I1 plus 5 by 4 Vs. So option A is the correct answer. The GATE 2009 question is a common data question. This is the data common, and first part is we want to find the transfer function. The options are given. Then the second part of the question is we want to find the state matrix. Here there are also options, but I am not write the options in the board. First take the Laplace transform of all these equations. So from equation 1 we can write s into x1s I am assuming all initial condition is equal to 0. This is equal to minus 3x1s plus s2s plus 2 times u of s. Here u of t is the input and y of t is the output. And the Laplace transform of the second equation by assuming all initial conditions 0 will give s into x2s, that is equal to minus 2x2s plus u of s. And the third equation we can write y of s, that is equal to 2 times x1s. So from equation 1 we can write this as s, this term can be taken to LHS. So s plus 3, this into x1s, that is equal to s2s plus 2 times u of s. And equation 2 can be write as this term is taken to LHS. So s plus 2, this into x2s, that is equal to u of s. From here we can obtain s2s, that is equal to u of s divided by s plus 2. Now substitute the value of x2s in equation number 1. We can write s plus 3, that into x1s, that is equal to 1 by s plus 2 into u of s plus 2 times u of s. Now take the LCM and simplify RHS. We can write this is equal to 1 plus 2 times s plus 2 divided by s plus 2, this into u of s. This is equal to 2s plus 2 into 2, 4 plus 1, 5 divided by s plus 2, this into u of s, that is equal to s plus 3 into x1s. From here we can write x1s, that is equal to 2s plus 5 divided by s plus 2 into s plus 3, this whole into u of s. Now substitute x1s in equation number 3. We can write y of s, that is equal to 2 times x1s, that is 2s plus 5 into u of s divided by s plus 2 into s plus 3. So y of s divided by u of s, this is our transfer function, that is equal to 4s plus 10 divided by s plus 2 into s plus 3. So this is our transfer function that is given in option number C. Now the second part of the question is to find the state transmission matrix phi of t. And state transmission matrix phi of t, that is equal to e raised to at. This is equal to L inverse Si minus A inverse. So our A matrix is A is equal to minus 3, 1, 0, minus 2. Si minus A, that is equal to S 0, 0, S minus the A matrix, that is minus 3, 1, 0, minus 2. This is equal to S plus 3 minus 1, 0, S plus 2. Si minus A inverse. This is a 2 by 2 matrix. Inverse of this matrix can be found by interchanging the main diagonal elements and changing the sign of off diagonal elements, that divided by the determinant. So this is equal to 1 by del. Del is the value of determinant of this matrix. This into matrix S plus 2, S plus 3. I interchange the main diagonal elements and change the sign of off diagonal elements. So this becomes 1 and this becomes 0. And del is equal to S plus 3 into S plus 2. So divide this matrix by del. So we can write del as S plus 3 multiplied by S plus 2. Now taking this term inside the matrix, so first element become 1 by S plus 3. this element become 1 divided by s plus 3 into s plus 2. The third element becomes 0 and this element becomes 1 divided by s plus 2. E raised to at, that is equal to L inverse of this state, Si minus A inverse. So we can write this is equal to L inverse of this matrix 1 by S plus 3. Then we can write this by using partial fraction expansion as 1 divided by S plus 2 minus 1 by S plus 3 and 0 1 by S plus 2. This is equal to the inverse Laplace transform of 1 by S plus 3, that is e raised to minus 3t. Second element become e raised to minus 2t minus e raised to minus 3t, 0 e raised to minus 2t. So this is the state transmission matrix. We have a network and we want to find the number of states required to describe this network completely. Options are given 1, 2, 3 and 4. So number of states is equal to number of energy storing element. For this network, we have two energy storing elements, this capacitor and inductance. So number of states required is equal to number of energy storing element, that is equal to 2. So answer is B.